welcome back. Hope you all have fueled up. And now with that, now let's look for the next session. We have Roshan Maskey with us, who will be talking on Cobalt Strike, a defensive perspective. Hi, Roshan.
Hey, Ali. Nice to be here.
Welcome to B-Side Islamabad. Yep, nice to meet you. Welcome to B-Side Islamabad. And you have 45 minutes to go and then 5 minutes for questions and answers. So, yep, stage 2 you.
Okay, thank you. Okay, good afternoon, everyone. Good afternoon, everyone. I'm Roshan Maskey. I'm a senior consultant at a security firm where I do, my role is basically incident responder. So as part of my day-to-day activity, I do investigation of compromise organization, security assessment, assume breached, and also purple teaming with red team with consultants. So in today's topic, I'm going to talk about a Cobalt Strike defender's perspective. So let's start with that. So who am I? This who am I is not a who am I as me as a person, but who am I as a malware. So if you read at this screen, there are a lot of names that it looks very generic name. But if you know about what this particular sample is, this sample is from one of the Cobalt Strike binary that I collected last year. So the problem with this one is when security analysts investigate malware detection based on what I can see on this screen and what you can see on the screen, it is not apparently clear to security analysts what they are dealing with. And this can lead into a closing ticket as a normal generic malware, whereas if it's a known Cobalt Strike sample, the response for that particular detection might be different as it is more interactive and hands-on keyword action. So in this talk, we'll be talking more about what we can know about Cobalt Strike Beacon and how we can detect that activity. So the outline of this session is first we'll have a quick introduction about Cobalt Strike, some of the components there. Then I'll discuss the study that I've been conducting over last couple of months and some of the observations I have discovered during my study, some of the characteristics, beacon characteristics that I have discovered, and some analysis technique for that. So let's start with Cobalt Strike. So the birth and the rise of Cobalt Strike. So Cobalt Strike, from what I know, started as a part of Red Team or offensive training course, and started somewhere in 2011, and officially I think the first release was in 2012. And then since then, the functions and features have been added by the author, and in the most recent version, there are a lot of features that are really impressive and gives a red teamer a advantage over some of the executions, and some of those we'll discuss as we go through. Now, who uses Cobalt Strike? So it was generally used by red teams, but then also in last few years where I have done investigation, I have also found nation state actors using Cobalt Strike. Now, they generally don't use just Cobalt Strike. They use Cobalt Strike as an additional access mechanism to the environment, in addition to their other malware, other backdoors, and other utilities. And as we go through the course, we'll understand why. Most recently, at least my first experience with the ransomware actor was late 2018, where 2019, I guess, where we saw a organization with the ransomware, and where they had Cobalt Strike as a mechanisms to encrypt the drive. So the way it was, the threat actor had compromised was using Cobalt Strike Beacon as a persistence mechanism, as a lateral movement mechanism, and selectively targeting the key systems where it did encrypt the systems using in-memory modules, so that there was no cryptor dropped to the disk. So why Cobalt Strike? So this is taken from Cobalt Strike website. It is adversary simulation and red team operation tool, and it does have a lot of capabilities. So mainly focused on post-exploitation capabilities, so that once the red teamer has access to the environment, can perform post-exploitation activities, including internal recon, credential dumps, lateral movement very easily and swiftly with leaving less traces to the operating system. The other cool feature that Cobalt Strike provides is a C2 profile. Now, this particular profile gives opportunity for red team consultant to modify some of the configs in how the implant communicates to the C2. And some of the features, if you look at Cobalt Strike, the author's GitHub page, there are various configs. So it can mimic traffic like Google, it can mimic traffic like Amazon, and there are also options uh, how you can encrypt the traffic or encode the traffic that is between the implant and the C2 server. It also gives configuration option for red team consultant to modify, to change the behavior of the implant on when it performs certain activity on the target system. In addition to that, it has a capability to built-in capability to run credential dumping activities for internal recons, and most of the tools that Cobalt Strike has as a built-in module are in memory, so they don't actually get returned to disk. And for that reason, most of your antivirus software would not be able to pick the evidence of these tools being run. In addition to that, starting with version 3.3, I guess, they had added another capability, which is in-memory execution of user bot binaries. Now, this particular feature is very interesting because prior to this feature was introduced with Cobalt Strike Beacon, uh, the only thing that Beacon Cobalt Strike was able to run was the built-in modules that the author has created. But with now in-memory execution, any .NET compiled binary can be executed in memory without dropping to disk. And this gives a red team operator a really good advantage over Defender. Beacon in action, this is just a screenshot to describe how console looks like. It talks about this is the host that has implant, and it has on the bottom section a console where the threat actor or even the red team operator can write commands that will be executed on the target system. It does also have some of additional capability, UI, GUI-based capability to do file transfer or review the process and things like that. But those functions are limited, whereas the command line-based executions is the primary way to use this particular tool. In terms of payload, so HTML application, this is most of the times red teamers' favorite payload that they use for phishing. So this is generally used for phishing. And when the red teamer sends this as an email and any user receives this particular file and executes it, the HTML application will establish a C2 communication to the C2 server. Now, in addition to that, there is a lot of way and options for payload generation. Some of the common one that I have seen during investigation and compromise are PowerShell based. The PowerShell, the VBA code, we have also seen the shell code itself, the DLL files, also executable at times, but I think DLL is more commonly seen in most of the engagement uh, that's being used. In terms of execution, so this is how this execution is how a beacon executes when we run certain commands using the console. So it has three different ways it can execute any instruction you provide it to the beacon to execute. Some of them are built in using Windows API, for example, ls or dir or change directory. it is written with Windows API. So when that particular activity occurs on the target system, there is lesser evidence of the execution recorded by your EDI software or any other software. The inline execution also leaves lesser trace in the environment, because what it does is it will inject into its own process memory and execute the code that it's supposed to execute. Now, the last one, fork and run, is the very common that I've observed during my study, used for most of the execution that, which is really interesting one and meaningful one, use fork and run mechanism. So what it does is, if there is a beacon process example, beacon.exe executing as a sample, when you run some of these commands like hash dump or login password, it will spawn a child process. And by default, the child process is run dll32.exe. And then run32dll.exe will execute the task that was instructed by the victim or threat actor. Now, the run32.dll is the default one, but most of the times what I've seen with working with the red team guys, they tend to change it because it is very obvious for them, and they want to be a bit more sneaky and have the successful compromise in the environment. They tend to change it a lot. However, in my experience and working with some of these compromise in the real world, threat actors did not care about changing the DLL or the spawn child process. It still ran run32.dll, which was a lot easier to track and detect. So now I'll go into section where I'll quickly talk about the study, what are the settings. So in this particular study, my objective was to identify as much as Beacon's characteristics when it runs on the endpoint, and develop a detection rule, which is mainly focused on Elasticsearch for me. In order to achieve my goal, there were some of the roadblocks, like there were some of the constraints that I had. So I had to remove all those constraints. So I did not use a multi-level city profile to customize anything. I just wanted to run as a default one at this stage. I required admin access to perform some activities for domain creates or doing DC sync with the domain controller. So I used that one without having to escalate privilege. And also, Defender was giving me a lot of problems, so I had to turn it off so that I could just focus on the runtime behavior of Beacon. So this was the setup that I used for my study. So everything was in virtual machines without going to the internet. The domain that actually I used is Google, but I had extra or 0 on that one. This actually results to Google, but this is something I use internally, so it did not actually go to the internet. Now, some of the components I required for my study. One was the EDR-like feature where I can get a lot of telemetry for data collection. So I use, for that particular component, I use Sysmont because it was freely available for anyone to use. And some of the data collection and telemetry Sysmont provides is better than some of the commercial offering as well. So that's 2 reasons I use Sysmont. Now I needed Sysmont configuration, so I use Swift on Security Sysmont config, which was really good. I had to modify a few settings for some of the common processes I used because the default config did not capture some of uh, the, the the components of Sysmon events. So I had to modify that to capture everything for this process, especially the process access, DLL email loading. Those events were not captured by Sysmon Swift on Security config. In terms of data collection, storing, and running query, I chose Elasticsearch and Kibana, which is again free for use. And to ship data from the endpoints to Elasticsearch, I chose WinLogonBit, and it was simple to use. So the only thing that I had to modify in the Swift on Security config was to add those parameters, which is shown in yellow, to the components for each and every events where it was not included. And for the process access, I had to use the one that's in orange that says any source image, if there is a access activity or activity from these processes, just track that one. This was just to reduce the amount of logs generated by Sysmon. Now, WinLogonBit, I use version 7.8 as far as I remember. And the section on the left is the default one. I did not have to modify anything, which was easy. The only section I modified was in the right, which was to point to my Elasticsearch server. So that was all was needed from WinLogonBit configuration. Now, after doing that, what I did was I ran multiple commands, and I spent time running multiple commands and reviewed some of our red teamers commands they use for different scenarios. There are lots of commands that are in supported by Cobalt Strike. I could not cover all of those in this talk, so I chose the one that is very commonly used and for varietemer as well as threat actor. This is for program execution. So the first thing generally when they get access to environment, these are some of the commands they execute on the local system. And Cobalt Strike provides you various ways to run the same command. And as I started running this command, I observed some of the unique behavior. First one is a shell, and you can see the one in the green is what you would actually run on Beacon console, and the one after that one is it shows the process creation line with the dash. So if you see there in the first one, it says cell who am I. So the beacon will start a command cell with /c and run the pass that argument. And then the command will start another child process, which is whoami.exe. But if you run execute the same command using execute or run function module, the beacon itself will create a child processes. Now, when you run this as a single binary or a single command, it does not look that obvious. But when the threat actor or red teamer starts running more and more commands using these mechanisms, when you see a suspicious process or odd process starting all these command line utilities, which you generally expect to be started by cmd.exe or PowerShell.exe, and that would make you suspicious. Okay, why so example, if the beacon was injected in Explorer, why is Explorer starting all these command line utilities? The other thing I observed was in the first one, if you see in the red one, it says cmd.exe/c in uppercase. I'm pretty sure that generally when we write the command, it is lowercase, and that's something hard coded within the software. So that is another interesting thing that we can track for potential beacon activity. It is not a strong indicator. However, if you see more and more of same cmd.exe/c uppercase, that would be a clear indication of beacon activity in the environment. This is very, very common in beacon compromise. So if an environment is compromised with Cobalt Strike Beacon, you would see event IDs like 7045, where you would see a service installed, and that has service execution or binary, something that looks like this. Now, the one section in the red, again, this is defined in the software itself, so this is not changed. You can customize, I think, but the code is the use. If you see the encoded base64 encoded content within your service, that is most likely Cobalt Strike Beacon or a Metasploit based persistence mechanism. Now we'll quickly go through how, if you ever discover something like this in your environment, how you go decoding it and find more information about this. So the first step is to take the base64 encoded content and use a tool called CyberSafe. It is really a very good tool. And using this particular tool, you can almost get to the level where you can get the shellcode from that particular base64 encoded content. Now, at the first round, you have to run it at least 3 times with different settings. So the first round, you take the one that you see in the services, put in as an input section, and then use two recipe here. First is to decode from base 64, and the second, as you decode it, it actually is Unicode character, so it will appear one character dot, one character dot. So what you do is you use another recipe, which is decode text, and then set that as UTF-16 a little Indian, and you bake it. And that, and after you do that, the content you get is in the output, so it's more readable content. Now, if you look at the readable content there in the screen, again, you see a base 64 encoded content there. So now this is, you take that base 64 encoded content and you run again second recipe to that. So when you take that base 64 content, if I summarize if you look at the text on the top, that is the summarized version of output of first recipe. So it will have a base 64 encoded data there. Take that data and put into next new cybersafe recipe and put that content there. Now, in this case, if you read the PowerShell script, it is base 64 encoded, and then there is compression. Now, what we do is we decode the base 64 content and we unzip it using gunzip. After that, you see another PowerShell script there, which is more close to the cell code execution or loading of cell code. So what you do is the content there is section is I think cut off, but the most interesting part after this one is when you look at the content, you see something like barcode system convert base 64. You will see another round of base 64 data there. And immediately after that base 64 content, you would see a for loop where it is XORing with value of 35. Now you take that base 64 content, put in another cybersafe, put that content there, decode it, and then you use XOR mechanisms to XORing that with decimal value of 35. And then what you get as an output is a cell code. Now you can click on the floppy icon there and save it. So once you have this, you save it, you should be seeing, I don't know if it was visible, it's not clearly visible here. You would see some of the clear text content, especially user as in a string, or sometimes you would see an IP address or domain for the C2. The content here is like cut off, but here, when I did this one, you would see the domain name of my C2 server, the hostname FQDN of the C2 server. Now you can take this particular cell code, and then if you have your sandboxing utility or a sandboxing software, you can chuck this to the sandbox, and generally they are good on decoding everything and give you the C2 IP address, and that will tell you, okay, this is where the C2 is connecting. So you get NBIs, and you can use that particular NBIs to scope in your environment and see how many other systems are talking to the same C2 server. And you can use Windows Event ID 7045 to hunt for similar services in the environment. So the another topic of interest is lateral movement here. So I did run a test on a lateral movement, and this is something that command that you execute. So this particular command is psexx, and this particular command is built in, not the psexx from sysinternal, but is the psexx implementation by the author of Cobalt Strike. So you pass the command remote exec and psexec. That is the command that you need to pass, and after that is user provided parameters. So what I'm telling here is run a PowerShell.exe and download a binary or some content from my C2 server and execute it. Now, in order for this to be successful, there needs to be firewall should at least allow for 5 communication between the system that has the source system, which is running a beacon, and the target system. In this case, is a 002. So the 445 communication is required for that to happen. And this is another. You can take this as an interesting learning that if you don't allow 445 communication between workstation to workstation using your GPUs, it will block this lateral movement activity using psexec. In my case, I had it enabled. So What I observed when I did PSXX is I observed that there are a few logons. One is 4672, which is a special logon that talks about special privileges were added to the user. And most of the time, the user is the same user that is running the beacon and the source system. You also see network logon, and the network logon is type 3 logon from the source system to the target system for the same user. uh, Sometimes it does capture source IP address, and sometimes I don't see source IP address for various region. Now, I don't know exactly which execution, but I have noticed that sometimes I don't see source IP address. Most of the time, when you see this activity, PSXX, the process, what it does, it creates a service. And now the service is very peculiar service. It is hexadecimal characters, A to F and 0 to 9, and it's only 6 character long. So if you have mechanisms to monitor event ID 7045 or 4697, you would see this particular service being created. 7045 does not record user information, whereas if you have enabled 4697, that will record the user. So it will tell you when you inspect on the system, what was the user account that created that installed that particular service. And this is important for your investigation, because this will tell you the user account that the threat actor or a teamer has compromised and leveraging to perform lateral movement. The other interesting characteristics I observed when a PSXX is used, it installs a service, the service, and then it executes, starts the install the service, starts the service, and within 30 seconds, when the execution is complete, it will stop the service. And while looking at Sysmon events, you can quickly check. There is no Sysmon doesn't actually log in the same way as your service does. So you will see service registry being changed from different values with start with 2 to and then disabling it after 30 seconds. One of the quick way to hunt for some of these activities, especially PSXX, is looking for a service which is with the pattern there, A to F, 0 to 9, and up to 6 character long. WinRM. This is another mechanism for a lateral movement, and I think earlier talk about APD38, they mentioned that they were using with WMI, WinRM, and PSXX, and these are the very common mechanisms a red teamer or threat actor generally use to pivot from one system to another system. Same command, just using a different mechanism. In this case, for WinRM, service needs to be running on the target system for this command to be successful. And firewall should also allow communication to WinRM ports for this command to be successful. And when you look at the command, you would see on the source system, encoded PowerShell script use. Now look at the section on the red. It is always the same. And this is what I believe is something configured in the software, so it's not normally changed. And it passes the encoded command. So when you look at decode the encoded command, again using the same mechanism, base64 encoding, decoding, and then UTF, you see the command being invoke command being used and script block being provided to download the command. Now, some other observations similar to observations similar to the previous one. You would see multiple logon activities, especially special logon that is special privileges assigned to the user. Again, this user will be same user that is running beacon on the source system. The logon network logon ID, which is type 3, source not always there. One other interesting thing I observed was instead of just having one logon to the target system, I did observe at least 3 to 4 logon activities. So I would see 4672, 4624, then I'll see another 4672, another 4624. Within the span of like 120 seconds, I would see multiple logons from the source system to the target system. I also observed that Sysmont capture that anonymous uh, named pipe was created on the source system and connected by the beacon process. So this is on the source system. So beacon will create this anonymous pipe and connect to itself. Uh, in the source system, you'll also see the PowerShell logs. And for the PowerShell logs, even ID 400, 403, and 600, you'll see multiple of 600. And in that, you would see a field called host application. And there you would see, again, the same command captured by a PowerShell log. And that's another avenue where you can look for if you're suspecting Cobalt Strike activity, you can look into that particular event log. WMI. Again, I'm executing a slightly different command here, but the same process here is target system is same. In this case, I did test use bits admin to execute command and get a cell to my console. In this case, TCP 135 communication was required to the target machine, and it negotiated a dynamic ports, and then the communication happened that transferred the file and executed the beacon in the target system. Lateral movement. In lateral movement, again, WMI, similar commands observed here, anonymous name pipe, similar pattern, nothing different than what we have seen in WinRM. So a very easy and quick way to hunt for this particular activity, if you're interested in lateral movement, is look at the PowerShell commands that is specified in red, which does not look like it changes. And if you just capture monitor for that particular command line argument, you will potentially find the beacon activity in your environment with Sysmont or any EDR software. So now let's talk to some of the beacon characteristics. So those were very common that is specific to one particular command execution. And the next section I'm going to talk about in general what I have seen during this activity. The run32.dll. So the run32.dll is a default process for spawning child process, and it typically runs with some DLL name and a function. But the way the beacon actually executes, it does not provide any DLL name. You will just see it on DLL32.exe without command line argument. And that is abnormal for on 32.dll. And if you see that, that is clear indication of beacon activity. Also, as threat actors run more and more commands, or red team run more and more commands, you would see more and more on DLL32 without command line execution in the environment in your tracked by your Sysmon or your EDR software. WinINIT.dll. So this DLL is used by Beacon to establish communication with the C2. This is loaded by a lot of genuine application as well. So it's very difficult to tell based on just by this if it's bad or not. But what I have observed in my research was if you see this particular DLL being loaded late, that is the process started like 2 days ago, and now suddenly it loads this DLL, potentially it is a beacon activity. Named pipe. So these are some of the default name pipes used for inter-process communication. As we have learned that most of the commands are fork and run, and the child process is created. So to transfer the message between the beacon and the child process, it uses a named pipe. And these are some of the common named pipes I have observed during my study. Now, customization of these name pipes are possible, and red teamers may do, but in most of my experience with threat actors, that they haven't actually changed it. I see just the standard default name pipes during the compromise. .NET libraries. So this is another interesting one. So this was with execute assembly, as I mentioned, in memory capability to execute .NET compiled binaries. And in order for that to happen, it has to load some of the DLL .NET framework DLLs like CLR DLL, MS-Code.dll. There are around 20-25 DLLs that it loads during the execution. But The interesting part here is most of the time what I've seen, even the red teamers, especially with the red teamers, they change the child process from run DLL32 exe to like var fault search protocol host. And all these service exes are native image that is C++ code, and they generally don't need .NET libraries. But if you, while monitoring your DLL image load, if you see and observe native image loading .NET library, it is most probably because it is executing some .NET based code. And that could be one of the ways we can track for the activity. Credential dump. So when we're performing credential dump, especially with the default config, if you see run dll32.exe accessing LSS or creating a remote thread to LSS, it is clear indication of process credential dumping using potentially Cobalt Strike Beacon. Windows services. So these are, again, we have touched on the Windows services a bit earlier, generally 6 to 8 characters depending on different config. The first one service path is admin $sign. I think it was also mentioned earlier in the earlier talk where when they changed tactic from WMI to PSXX, you would sometimes see this particular path with admin dollar and random characters being referred in your service path, and that is clearly an indication of either Cobalt Strike Beacon or Metasploit activity. The second one is more or less Cobalt Strike activity. Okay, so we have learned a bit of beacon's characteristics. Now, how about going and investigating them? So ideally, if there was a way I could just point and say, okay, this process looks suspicious. I point to analyzer and say, hey, analyzer, can you tell me if this is a beacon or not a beacon? That's my goal here. And this is what I actually wanted to get to this stage. So in order to get to that, as I have mentioned that I have used Sysmont for events, and these are some of the events that I was tracking and have used to understand and determine if it's possible to identify beacon activity. This loosely maps to these beacon uses. So process creation, network, image load, remote thread creation. These are some of the common things. And based on my study, what I found is at least for each and every post-exploit execution, at least one or more of these activities are observed. Now, this does not include Windows event logs, Jaeger event logs. Those are in addition to these event logs. And these are some of the mappings. I would not actually go in detail about this mapping for now, but this is something you can later on refer when you get the slide. Now, Process 360. So I came with this idea because long time back, during a different organization I was working for, there was a annual process to review everyone's performance. And the way they perform the performance review was 360 evaluation. So a manager's review will be including the DRs and its manager. So I thought maybe I can use the same concept here to identify if I can tell doing process 360 review if a process is a beacon or not. So in this process, I'll evaluate everything a process does, its child process does, its parent process does, and its sibling process does. And will that tell me if this process is a beacon or loosely linked to beacon activity? So to do that, as you see, there are almost 10 to 15 different events captured by Sysmon. And for each those query, I had to manually run query, review the content, and mark them as related to beacon characteristics or not. And it was easy for me to do when I started with one commands or two commands. But as I started running more and more commands, it was not feasible for me to manually review them. So I had to have some automation in place. So I started writing a small code to help myself and This is what I actually ended getting into. I ended building a tool called Go Hunt Beacon, where what it does is it automatically runs the queries, maps the relationship, applies the rules to check some of those detections that I have observed, like run DLL32. Is it running with command line argument? Is it loading CLR.dll or win9.dll? So all those things that I have learned during my study, I put into this particular code, and it looks for those activity. Now it's not complete yet, so there are sections where it's missing, which is I know for a fact is a beacon behavior, but I have not actually gone and implemented that in a code. So this is a very simple command line. Just point you to your Elasticsearch server. And the preferred method here is to hunt for a specific one process. It does give you option to hunt for based on other Win98 or CRT, which is create remote thread, but it's not as perfect as targeting a specific process. Now, this is the first command. So this is a purely a first implant in the target system. I ran the first command, which is VMI, to understand what I'm doing. After I ran that command, I executed my tool that I developed, the Go Hunt Beacon, with the parameter I passed, and wanted to know what do I observe when I run this whoami command using a shell mechanism. So when I ran that particular output, I did observe a few things here. It talks about beacon-related named pipe detected, which is MSSE. And it talks about anonymous name pipe being created and connected. I did not actually know that for even just one command, I would observe that. But these are some of the things it talked about, it identified. Now, it also talks about loading a Win9 DLL, and it says it's loaded within 5 seconds. So typically, when your process starts, everything that's mentioned in IAT are generally loaded within like 5 to 10 seconds of process starting. So there was nothing suspicious about that at this stage. However, looking at the name pipe, it will be very clear that this is a beacon activity. Now, in regards to the child process, it spawned a common cmd.exe, and that did not exhibit anything like beacon-like characteristics. Uh, then I spent around running like 10, 15 different commands. And after running 10, 15 different commands, when I look at the process parent process, I ran the same command. So it was the same command executed again from the Go Hunt Beacon with same parameter. But after running 10, 15 different Cobalt Strike commands, you will see this report on the left generated for the parent process, which is beacon.exe. And you see a number of anonymous name pipe created, a number of, I think, one MSSE name pipe created. You see another randomly character alphanumeric name pipe being created, which is again another beacon characteristics when it wants to communicate with the child process. And if you look at the bottom, it says, as I see more than one child process created, it says that there is a run DLL32.exe without command line argument, and it also gives you the number of times the same child it has seen in the environment. On the right, when you use beacon hash dump command, which dumps hashes, it tells you that the beacon run DLL30.exe. So it's supposed to say win inet, but I think it's missing there. And also says it access LSAS is injected to LSAS. It also created an anonymous name pipe for communication between the child process and the parent process, which is again an indication of beacon activity. When I ran this particular run ipconfig, there was no such activity detected. When I ran again a login password, there again similar characteristics detected for that particular child process.
Thank
So
you,
what
Roshan.
that tells,
We have a couple of questions as well before we're running out of time. So,
yep, sure.
this
I'll
question
wrap
we
it
have,
up.
yep, quickly go and then I will a couple of questions.
Sure. So this is again when you move migrate one process from one process to another one. this is what you would normally see. And this is what I was referring to. You see VirtualBox loading Win9 DLL after this many seconds, which is again indicator of Cobalt Strike Beacon. In conclusion, what I'd like to say is Cobalt Strike Beacon is really popular and very powerful tool for red teamers. Lots of features. Antivirus may detect the binary, but may not actually have names, so analysts would not have clear indication. With EDR telemetry, hunting for beacons characteristics is really possible. And that's the conclusion of my small study about Beacon. I'd like to thank Luke for providing me guidance and help with the process, the author of Red Team for providing awesome video to video, and the guys from Sysmont Security for having awesome Sysmont config. These are some of the references, and thank you.
Thank you, Roshan.